That is not bad at all. That looks pretty good. Oh, hello everybody. Welcome back to the channel. This is Michael, KE4EST. And here I am back with the RCA VTVM, or Vacuum Tube Voltmeter. The Senior Voltohmyst, Whiskey Victor 98 Charlie, or WV-98C. Okay, so I think, in the end of the video I showed you, we went over the schematic. I showed you everything I did up here. And what I replaced and what I set up wasn't a whole lot. The only thing I did have comment on was about soldering the battery in. And you have to do that really careful, and have like a wet rag or something ready to cool it off real quick, as soon as you heat it up and put it on there. You want to, prepare the surface, scratch it up really good, rough it up with a piece of sandpaper, clean it, make sure it's dry. Use a little, what I use is I got a little, I've stuck it in the drawer, I guess, but I use a little flux pen, put a little flux on it, heat it up, with the soldering gun, stick it to it quick, and then cool it off really quick. And yeah, it was one of those things that was like, I didn't have a battery holder handy. I could have rigged up something. So my thought process on that was, well, I can do that, or I guess I can just solder it to it, and it'll probably outlive me, unless it's abused or something. Those batteries, they don't, as long as the battery don't leak or anything, go crazy or whatever. Of course, these newer batteries ain't made as good as the older ones, but as long as it don't leak or anything, that thing will, years and years and years from now, it'll still, be fine. It'll still read just fine, work just fine. And this unit, because it don't use a whole lot of, current, because it's just for the ohm section when you're reading resistance, and it don't use a whole lot. So yeah, it was one of those toss-ups, whatever, and it's like, if I find I have a problem with it or whatever, and I start using this a lot or something, I'll probably, and I have a problem with it, I was like, well, I should have listened and to the other guy and went with it. But it's personal preference. So, but I wouldn't get too caught up in, if that's what you don't have anything, any other way to do it, and you want to restore one of these, and that's the way it's done, you want to do it. As long as you do it carefully, pay attention to what you're doing so you don't overheat the battery. It'll last for a long, long time. So anyway, so there's that. And I am at, I think, step 4 or 5 here in the alignment procedure. Just sitting here with it on. I didn't want to take too much time. So what I'll do is I'll back up a little bit, and we'll go over the alignment procedure from part 1. And the first thing you want to do with these, any of these older meters like this, or newer meters or whatever, but any of the, these analog meters, is there's a mechanical adjustment in here. Now some of them, like the one up here that I did, a couple years back, the Heath kit, it's got a little screw that you can just turn. And I wish I had one laying here, but the back of that screw has just got a little pin sticking out that sticks in a little slot, kind of like this, but this is closed up, but it's more elongated like this, but it's closed on the bottom. And that little pin just sticks in there, and the pin's offset on the circle part of the screw back there. So as you turn it, it's going to cause this to do this. If you turn it back this way, it's going to cause the whole thing to shift this way. So that's what's going on with that. And this here don't have that screw, so you got to stick in something. It says a scribe here or similar tool. Find you something to stick in there, and you got this little elongated piece you got to stick in and move it very carefully and gently, one way or the other, to put this on 0. And so what you want to do with these is, if you've had it plugged up or whatever, messing with it, unplug it, put it to the off transit position here, and make sure it's unplugged, and let it set for a little while so everything discharges and there's no magnetic fields or anything around, because it's pretty sensitive. And then you want to go in and just look at it dead on, and you see this has got a mirror in the back. So when you get your what you want to do is look at that 0 here and adjust that so that when you don't see the reflection in the background of that needle, you know, you're lined up right on with it, you know. But you want to do all that with the meter off, turned off, been off, unplugged, all that. And it tells you here, caution, you know, big word, big letters here. Extreme care must be taken in the next step to prevent insertion tool. To prevent insertion of the tool to a depth which will injure the pointer spring. So, you know, don't jab that thing up in there. You can get where you can see it, just barely go in there and touch it if you have to. Okay. And then insert a scriber or similar tool. Like I've already mentioned, and adjust that to 0, and then replace the plug, which I've got the plug laying over there, but I've still got to put the case on it and all that. And then electrical balance check, set the function selector to DC volts, and allow it to warm up for about 15 minutes, which this has been warming up for a while, but we'll put it over on 15 volts. I had it on 50 volts, messing with this battery here. I checked this battery on the other meter over here, and it's a little bit less than 9 volts, like 8.8. And this here's reading right below that, so it's not bad. But anyway, go to 15, select 15 volts there. That's on, it's just I ain't got the case on, you can't see that hardly. You probably, if I do, yeah, so you can see if I do that. But that neon indicator is working. But it says here, rotate the 0 adjustment control. It should be possible to set the meter pointer at either 0 or 60% of full deflection on any range. Well, I mean, I think I'm double reading here or something. That one 15 minutes. I don't know why I had on 15 volts range, but anyway, what they're saying is you should be able to go at least 60%. So there's about 50, 60, 70, 80, you know, or almost. So that's not bad. Go back to 50 here, and then on the DC, on the negative DC volts, you should be able to run the 0 at least 10% of the full scale deflection. So it should be able to go up and, you know, way past 10%. And this is about 60 is where that's going to go. And put it back there. I'll 0 that in a minute. So that's what they're saying there, and what it's also saying is on the next page, if you can't get it to do that, you try that and you just can't get that to happen, then there's an unbalance between the two travel sections of the 12AU7 bridge tube, and it should be replaced. Now also, you could have, let's see, where did I do with it? Let's look at this schematic. Wrong side. It's off on 2 pages here. Here's a schematic, this tube here. See how it's making a balance here? And if you can't get that, then this tube, you know, one side's, you know, that's what the 0 is for. You know, if this tube could be in a perfect world where both sides match perfectly, you wouldn't need that 0 set. But it's not a perfect world, and one, you know, may be a little more tired than the other side or whatever, so that's what that's for, the 0. If it gets to the point where you can't 0 it out, then you probably can replace that tube and you'll be fine. If not, you know, check these 10K resistors here, and this 10K potentiometer, and these 330 ohm resistors here in the biasing circuit on the cathode, and make sure all that's there and soldered in, and not got a cold solder joint, or, you know, bad, you know, the resistance is okay and all that, pretty close to 10K, and that should take care of that. It didn't say that in the thing, but I just want to let you know that they'll most likely take care of it. Okay, so now let's see, check that the 0. Okay, we did that. Step 1 here is checking that mechanical 0, which we did on the other page. Okay, turn the positive DC volts, allow it to warm up for 30 minutes. Check the line voltage. I already done that. Turn 20 volts. Rotate 0 control to bring the pointer to exactly 0. And what I find that works the best too is if you short these out and make sure it's in the DC position. And your probe, if you didn't watch part 2, may look different than this one. This is not the probe that came with it, but it's right. It's got the right resistor in it and all that. It's just a different brand. I don't have the one that came with this. But if you short them out there and then 0 it out, Like I say, it may look a little different in the camera because there's an angle, but that's 0 right there. Okay. Alright, connect the ground cable clip to the negative terminal of a DC voltage source supplying exactly 50 volts. The switch on the probe, it's saying, should be set to DC. Connect the probe to the positive terminal of the source voltage. With a screwdriver, adjust the positive DC cal potentiometer R19 to bring the pointer exactly to the full scale 5.0 mark on the 0 to 5 DC scale. So what, if you're not familiar with these, you've got a 5.0 here and you get a 15, we're looking up here. If you're on 0.5 volts down here, this would be 0 to 0.5. Just move that decimal over. It's in your head, you have to say, okay, that's 0.1 volts, 0.2 volts, 0.3 volts. If we move to the 1.5 volt setting here, then we drop down here and use this scale, which is 0 to 15. But this would be 0, 0.1, 0.2. This would be 1 volt. This would be 1.5 over here. And so on and so forth. 5 volts is going to read exactly, on that 5 volt scale. 15 volts would be normal 15 volts. At the 50 volts, we're in the 50 volt multiplier, so the 0 to 5 volt scale is going to be now 0 to 50 volts. So this would be 10 volts, 20 volts, 30 volts, 40 volts, and 50 volts. So I'm going to see if I can got there where you can see the image of the light back on it. I'm going to adjust right there. Okay, so I have got a 50 volt source here set up, and I just checked it with my other meter, make sure it's spot on. So I'm going to take this and go here, and take this and go here, like that. And then we're going to turn it on. I've not touched it, I promise. There's no adjustment needed. That's dead on 5.0. It's not bad. Well, that ain't bad. Okay, and then it says, well, I should have, if I know that, I'd went in and off camera twisted it just a little bit. But the potential on the back, you have to adjust to make that 5.0. Reverse the test leads and set it to negative volts. With the screwdriver, adjust the DC negative potentiometer R20 to bring the pointer to exactly 50 volts on the scale. Okay, so let's do that. Make sure that's on standby over there. I don't want to get zapped with 50 volts. So let's reverse it. Aha! Well, let's make sure. Make sure we're on 0. I always zero it out each time you change your range. Sometimes you'll have to. Alright. Okay, now we get to do some adjusting. So, I gotta move this just a second. Make sure I'm on the right one. And we'll turn this. Oh, too far. Right there. Alright. Okay, that takes care of that. And then go through and check the 1.5, 5, 15, 150, 500, and 1500 volt DC ranges against other DC sources of known accuracy, which provide full scale deflection. I'm not going to go through all that right now, but you want to go through and check it. 1.5 volt battery is easy to get a hold of, and a 5 volt source, if you get a power supply, and a 15 volt source, and so on, 150 volt source, 500 volt and 1500 volts. You may not have that DC laying around, which is fine. If you do, use it. I can go up to 500 volts, but no, actually, it just goes over 400 volts on my high voltage supply over there. So I wouldn't even be able to go all the way up, without setting up seriesing up some stuff or something. So anyway, and then set the range switch to 0.5 volts position. Okay, so we're going to come down here all the way down, and I know it's always going to be off. This is connect the probe and ground clip together. No, wait. Touch the probe tip to the ground clip and reset to 0. Adjust control so that the mirror rests on 0. Then connect the probe and ground clip to a DC voltage source supplying 0.5 volts. Okay, so I've got that set up right here. You can kind of see it there. First of all, we make sure that this here is zeroed. Alright. And then let's see how close it is here. Well, I said I had that set up. Oh, I see something's came loose here. Well, it was set up. Try that. On the wrong one. Let's re-zero this out. Okay, it's zeroed. And it's... So now see, this is 0. This is 0.1, 0.2, 0.3, 0.4, 0.5. And it's not quite, is it? So I'm going to put a tool back here. Yeah, I didn't know it was going to be that complicated to get in the hole. Let's try a different one here. I think I got it. Oh, that ain't working either. Hang on, bear with me. Let me have a look in here. Oh, I see. We're going to have to choose something else here. I wasn't prepared for that. Hang on just a minute. Maybe that'll work. Yeah. Okay. Let's try this again. Here we go. And that part is set up. Turn that supply off too over there. Okay. And that's going to come back down. That's just the way that 0.5 volts is real sensitive. Okay. See how it's still going crazy? It's just picking up noise. See, I touch it. Okay. Now, so we've got that done. And we're on here now to the AC calibration. Set the switch on the WG299D. If you have the actual probe that came with it, it'll be an RCA, WG299D to AC, and that'll be flipping the switch back here to AC. Set the function selector to AC volts. Set the range selector to 1.5. Okay. AC. Short the probe to ground and adjust AC Z potentiometer R33 so that the potential rests exactly at 0. If a 0 meter reading cannot be obtained, replace 6AL5. Okay. So we're going to clip these together. And then in the back, there's a AC 0 adjustment, which is right here. And we're going to adjust that to put that right on 0. And then, and it may go off of it a little bit when you take it loose, but don't worry about that. Now, set the range switch to 50. And apply 50 volts. Okay. And I've got that set up here too, very carefully. On a different supply. I'll let that hang there. Set that there. Touch that. Everything looks okay. I don't know if it'll go to 50. Turn that on. Okay. Now we're going to adjust the AC. So, there we go. Turn that off. And that takes care of setting the 50 volts, or the AC section. Now, for the ohms adjustment, the battery must be installed for resistance measurements. Obviously, set the function switch to positive volts and make certain the pointer is at 0. So I'll go back to here. Make sure this is on 0 with the 0 set. Turn the function selector to the ohms position. Set range control to R times 1. So R times 1 is there. That on ohms. Turn the range switch to the R1. Oh, adjust ohms adjust control for full scale deflection. And that'll be the infinity symbol. And here's your ohms adjust over on this side, so we'll bring that to where it's right on the infinity symbol. And then turn range switch to R times 1 meg. Should be all the way up. The meter pointer should read above 1000 on the resistance scale. If the pointer reads a lower value, there's excessive leakage in the ohm meter circuit. And we are past 1000. It did go a little past 1000, if you notice that. We come down to times 1. Whoop, times 1 here. See, I got it on infinity. Now we move it up. See, it went up just a little bit. If necessary, we adjust ohms adjust control when changing from a low position range to the 1 meg position. R times 1 meg position. Section on the tube placement below. Refer to the section on the tube placement below if it is impossible to obtain a full scale reading of the pointer on ohms adjust. And it goes into your replacements and all that. And then it's mainly saying to anytime you change your range, just always make sure you're at infinity there. And I like to just do this, because if you go to DC volts and then go back, see, we're reading right now, it's reading properly. If I come down, it should go up. See that? It's going to infinity. And we're getting a little over about 1 ohm. It's reading the resistance through all this here, and you see as I move this, this ain't perfectly set right here. And I'm touching it and all that. But if I zero it out here, I zero out this wiring here so I get a more true reading when I'm measuring something. So, anyway, that went a little longer than I thought it would, but we went through it and got it. So, there is the adjustments and calibration on this RCA WV-98C. And it likes to bounce as I'm talking here. What is... Oh, I know what's going on. Okay. But anyway, turn that off. So, I hope this helps you if you have one of these and want to get it set up and get it going, and watch part 1 and come back and watch part 2. Set it up and, you know, have your meter going. If you have any questions or comments, just post them down below the video. I'll be glad to answer them. And most of the time I get to them pretty quick. Sometimes I'll miss them. And it ain't because I miss them on purpose. It's sometimes YouTube don't tell me, but it's supposed to ding my phone every time somebody comments or something. So sometimes it don't. Maybe they're trying to keep it not too many comments, you know, so you don't go crazy or something. Of course, you can turn that off. So, you know, these people that's got 10 million subscribers, you know, they don't have that on. Their phone dings every time they get a comment. They, you know, wouldn't be able to do nothing, but their phone would just ding constantly. But anyway, so until the next video, this is Michael, KE4EST 73.